Assalamualaikum warahmatullahi wabarakatuh. Hi guys, good morning. My name is Ria Lutfiah Muhdy from 11.1. Today, I would like to finish my physics assignment. I want to share my explanations about wave behavior. Enjoy the video. Wave behavior. Wave. How many wave behavior? Wave behavior have 7 behavior, which are reflections, refractions, diffractions, interference, constructive interference, destructive interference, and Doppler effect. But before that, let me explain you what is wave. Wave can be described as a disturbance that travels through a medium from one location to another location. This is wave. Next, going to the first behavior, which is reflections. What does it mean? Reflections is the event of returning all of a part of a particle or wave beam when the beam meets the boundary plane between two mediums. A line or surface in two or three-dimensional medium through which a wave passes is called wavefront. This wavefront is the locations of the points that experience interference with the same phase, usually perpendicular to the directions of the wave, and can have shapes, for example, circular wavefronts and straight wavefronts. You can see the picture. There is constructions of wavefront diagram. There is incident ray, normal, and also reflected ray. And there is the reflector. Next, what is the law applies in reflections? In the event of reflections, as shown, a law applies, which are the incident ray, the reflected ray, and the normal line to the boundary plane of the reflections at the falling point are all in one place. And then B, angle of incidence, or we call it OI, equals to angle of reflections, we call it OR. This law is called the law of reflections. You can see the picture. Okay. What is the example of reflections? The example of reflections are: when you're shouting on the hillside, your voice will be beat again. Reflections of pool water waves by the pool wall. Reflections of sound waves by the seabed. This is the picture of reflections of pool water waves by the pool wall. Going to refractions, the second behavior. What does it mean? Refractions is the change in the directions of the wave when the wave enters a new medium, which causes the wave to move different speed. In refraction, there is a change in rate of propagations. The wavelength increase or decrease with the change in speed, but there is no change in frequency. You can see the picture. There's the light rate, and then wave crest of light, air, the light wave slow down into the water, and there's the water. The blue one is the water, and then the speed of light can be compared between media. N1 V1 is equals to N2 V2. Let me explain to you specifically. In this figure, the wave velocity in medium 2 is smaller than in medium 1. In this case, the directions of the wave bends so that its propagation is more nearly perpendicular to the boundary. So, the angle of refractions is smaller than the angle of incidence. The incoming waves from medium 1 to medium 2 experience a slowdown. Wavefront A at the same time t, where A1 is traveling as far as I1 is equals to V1t, it is seen that A2 propagated as far as I2 is equals to V2 times t. The two triangles depicted have the same side, namely A. This is the picture, figure 2. What is the example of refraction? The example of refraction are: the sound from the land is biased in the depth of water. the light emitted to the sky will be refracted. This is the example. So you can imagine about refractions. Yeah, there is 3 picture here. Going to the third behavior, diffractions. What does it mean? Diffractions is the event of spreading or deflecting a wave when the wave passes through the opening or around the end of the barrier. The amount of the diffractions depends on the size of the barrier and the wavelength. Wave spread is influenced by the size of the gap. So, the smaller the gap, the wider the wave spread will be. And the bigger gap, the narrower the spread will be, and the diffractions will not be clearly visible. You can see the picture. In the left there is small gap, and in the right there is large gap. How many kinds of diffractions? There are 5 kinds of diffractions, which are Fresnel diffractions, Fraunhofer diffractions, single slit diffractions, multiple slit diffractions, compound slit diffractions. Let me tell you about them. Kinds of diffractions. First, Fresnel diffractions is the diffractions that occurs when the locations of the light source slit and the observation screen are close together, usually called closed diffractions. Also use a wide slit and have a sharp edge at the edges. Second, Fraunhofer diffractions is the diffractions that occurs when the locations of the light source slit and observation screen is at a great distance. Therefore, the waveforms that enters the gap is flat or planar, and the diffraction pattern has a constant shape and intensity. Third, single slit diffractions. A barrier that has a single gap is used. Each edge of the gap will produce a new wave or act as a wave source. Waves generated on one edge of the slit will interfere with the waves originating from the other edge of the slit. Fourth, double slit diffractions. A double barrier is used, so the 4 new waves are generated. Because each slit produces 2 new waves, the 4 waves will interfere to produce a dark and light pattern on the observation screen. 5. Compound slit diffractions. A barrier that has many gaps or lattice is used, so that it will produce many new wave sources, all of which will interfere with each other to produce a diffraction pattern. What is the example of diffractions? The example of diffractions are when you're shouting in a closed room but with a slight gap, the wave will be bent or spread through the gap. This is the picture, so you can imagine it. Next, the fourth behavior, that is interference. What does it mean? The interaction between 2 or more waves motions affecting a part of the same medium, so that the momentary disturbance in the alloy wave is the number of factors of momentary disturbances in each wave, which is an explanation of the interference phenomenon occurs into coherent waves, namely waves that have the same frequency and phase difference. In rope waves, if 2 rope waves propagate in opposite directions, when they meet they will interfere. After that, each of them continued on his way as before without being affected in the slightest by the interference even it had just experienced. If the 2 waves combine in such a way that these crests arrive at one point simultaneously, the amplitude of the combined wave is greater than the original wave. This combination called mutually reinforcing. The point that experiences such interference is called the belly of wave. However, if the crest of one wave arrives at a point along with the bottom of another wave, the combined amplitude is minimum. Interference like this called mutual interference or destructive. Inference 2 water waves can be observed using a ripple tank with 2 circular wave generators. You can see the picture. There's this resultant wave, there's wave 1, wave 2, and the left picture is constructive interference and the right picture is destructive interference. What is the example of interference? The example are music. Why music? Because music is formed from combinations of several sound waves that interfere with each other, so we can hear music. Pool water looks colorful. The occurrence of Newton rings. You can see the picture, there's a soap bubble interference color, so there's so colorful. Next, interference. How many types of interference? Can you explain it? Of course, I can explain it to you. Interference have two types. Interference is an event joining one wave with another wave. If the two joined waves have the same phase, the meeting of the two will produce a new, stronger wave. This phenomenon called as a constructive interference. And the second types of interference is if the two joined waves have opposite phases, they will cancel each other out and produce a new weaker wave. This phenomenon called as a destructive interference. And what the example of constructive interference? The example of constructive interference is two speakers playing same music while facing each other. And the example of destructive interference, gravitational waves are a specimen, light beams demonstrate, and moving electrons and radio waves. And this is the last behavior, the seventh behavior, Doppler effect. The Doppler effect is the change in the frequency or wavelength of a wave with respect to a moving receiver relative to the source of the wave. A scientist from Austria who first gave an explanation of this event, Christian Doppler. The one who was silent heard a voice from a voice source who was also silent. The sound we hear will have the same frequency as the sound source. However, in the Doppler effect, the source of the sound is something that is moving. The closer the object is, the greater the sound frequency. What is the utilizations of Doppler effect? The utilizations of Doppler effect, there is two, utilizations of radar and utilizations in health. In utilizations of radar, the Doppler effect is utilized in various types of radar to measure the speed of the object by the object being observed by measuring the change in the received frequency. In utilizations in health, one form of exploiting this effect in health is the echocardiogram, a medical device that uses the Doppler effect phenomenon to accurately measure the velocity of blood flow and tissue characteristic. How about the example? Can you mention it? Of course, I can mention it for you. The example of Doppler effect are acoustic Doppler current profiler, or we can call it as ADCP, siren in ambulance, police radar gun, audio applications. Of course, you notice audio applications. Maybe the applications is in your handphone or your gadget, and also the last is satellite. I think that's all my explanations about wave behavior. I hope this video will be beneficial for you. Thank you. Any questions? If you have a questions, you can comment below, and you can find me at Ria Lutfiah. Thank you.